for my project for class.
14 out of 33. Okay. So let's see. This week we're going to talk about data mining. We're going to do some data mining with some software called RapidMiner. It's pretty cool software because it's better for people that like visual software. It's got a good graphical interface. We're going to do some of the things that we're going to do across this program, but it's good for demonstrating how data mining can be done, but it's not as good at actually doing real full-scale data mining projects. But yeah, we'll start out. I'll talk about data mining because we haven't really talked about it. That should take about half an hour, and then after that we'll work on the assignment, and I'll step through it for anybody that hasn't taken a look at it. Check this all set up. All right, so we will be talking about data mining, which is a method to develop intelligence and actions from data through organization and analysis. We will go over the many areas that use data mining applications, various software tools, and kind of the myths that accompany it. So let's get started. So data mining has risen as there is more competition in business. Becomes more global, and there's an increase in the amount of data. As companies begin to use the data to make advancements and improvements, the value of data and finding meaning in that data gained has become recognized. So data now comes from everything the company is doing, and this allows for improvements in each area of business. As data warehouses became common, the ability to store the data and improved along with improvement in processing speeds with the more powerful computers and abilities. So as the technology progressed, it also became less expensive and more digital. What was once, papers and filing cabinets has now been digitized in databases. So it's in a much better format or it's better formatted to suit doing analytics on. So data mining is the process of discovering knowledge from large amounts of data. This term can be a bit confusing. My wife always thinks that it is when I scrape data from the internet with Python or gather data in a similar way, but it seems like it's more like data mining. We have to think, or it's more like mining. We have to think of the gems that we are mining as the insights that we gain from the analysis. Because of this, it can have many other names that have a similar meaning, like knowledge extraction, pattern analysis, knowledge discovery, information harvesting, pattern searching, data dredging, but data mining is the most common term, probably followed by knowledge discovery. So data mining is a process with many steps that uses some types of experimental search to discover patterns with a degree of certainty. The discovered pattern should be new and not previously known and lead to some benefit for making better business decisions. So data mining is used by many different disciplines, including statistics, artificial intelligence, management science, and informations through mathematical modeling, pattern recognition, machine learning, and databases. All these figures always separate artificial intelligence and machine learning, but generally they're grouped together. So data mining characteristics and objectives. There are some common characteristics of data mining. Usually the data used for data mining is in a data warehouse and uses an information systems architecture. Of course, data is the most important part of data mining, so having good data and a usable format is necessary. The person mining the insights is often the end user, potentially the decision maker, And gaining the best insights requires creative thinking to look at the data in new and interesting ways. And ease of use is one of the most important qualities of the data mining tools. So the data is the most important part of data mining, obviously. The data is usually what is collected through experience and observations. It might be numbers, words, or images. Data is necessary to derive knowledge and information. So this image shows the taxonomy of the data sorted by structured or unstructured, where the structured data is then sorted into categorical or numerical, which is then further broken down into nominal or ordinal, and interval and ratio, and those are the basic data types that we typically work with. The unstructured data is further divided into text, which we're going to do some more text mining today, multimedia, which will be like videos and pictures, and then you have HTML, XML, which is what websites are made out of. So data mining extracts patterns from data by building models. There are 4 primary types of patterns: association, prediction, cluster, and sequential. Association finds groupings of things that commonly occur together, like the beer and diapers example that we talked about previously. Predictions show future occurrences of events based on what has happened in the past, like predicting the winner of the Super Bowl, which I don't think is ever very accurate. Clusters identify natural groupings based on their characteristics, like separating customers based on past purchasing behavior. That's an unsupervised machine learning algorithm that we'll work on in a future class. What's the last one? Sequential. Sequential relationships look at time-ordered events, like a customer opening a savings account within a year of opening a checking account. So patterns are often manually extracted from the data, but as we move forward, automation is becoming more common and necessary as the volume of data increases. So basically, a lot of this could have been done manually with lower level software, but now we need to write. This is why you're going to learn R or Python to write the scripts necessary to do data mining in a more automated way. So this table shows the data mining tasks sorted by the learning method and the most popular algorithms associated with them. We will talk more about these in this presentation a little bit, and as we move through this semester and the next couple of semesters. So prediction encompasses forecasting and is the act of telling the future using past data, whereas classification is the most common type of data mining task as it analyzes past data to predict future behavior using neural networks and decision trees. So in the spring class, we're going to build regression trees, neural networks, support vector machines. I don't know if we'll do genetic algorithms. We will do lots of regression, linear, possibly nonlinear, probably that gets a little harder. What else? K-means we'll definitely do as a type of clustering algorithm. And we'll do more stuff beyond this, so it's on this list. So data mining tasks. Visualization can be a part of data mining, as well as to gain a clearer understanding of underlying relationships, and it has gained an increased importance over time. Data mining shares some similarities with statistics, as they both look for relationships in data, but data mining is more about exploration and discovery than answering specific hypotheses. Some data mining applications. So data mining is used to address many complex business problems. So let's look at some examples. CRM, or customer relationship management, is an extension of traditional marketing with the goal of creating relationships with customers by understanding their needs and wants. This maximizes gains from marketing activities, improves customer retention through churn analysis, and maximizes value by knowing when and what to cross-sell and upsell, like do you want fries with that? It also allows companies to identify and reward their most valued customers. Like at my local grocery store, I got a free gallon of milk, but no cookies. So, in the banking industry, data mining automates loan processes by predicting those most likely to default on their loan, which we're going to spend a lot of time with. You kind of already saw the Lending Club data. but we're going to do so much more with it once we start looking at it in R. It is also used to detect fraudulent activities, identifying customers that would be interested in additional products or services, and predicting where money is best spent in adding ATMs and branches. So applications continued. In retail data mining, it is used to predict sales volume by location, to ensure inventory is available to support sales and to improve the store layout, and to optimize the promotions and discounts on products. It is also used to predict seasonal fluctuations in sales and to look at the movement of products to ensure the right amount of goods that have limited shelf life, like milk, are not overstocked. In manufacturing and maintenance, data mining is used to predict machine failure and optimize the timing for maintenance. It also looks at the ways to optimize manufacturing schedules and capacity while improving product quality. So I think it's funny that the example is limited shelf life like milk, but anytime you go to the grocery store, you guys look at the dates, right? And you always grab the one that has like the most time on it, and then this one that's going to expire tomorrow gets lifted. I don't know how the store is going to overcome that one, but probably through the use of data mining. Okay, so let's see what we got. Brokerage. Okay, some more examples. In brokerage, data mining is used to predict when bond prices will change, forecast the range and direction of stock movement, determine the effect of movements in the market, and detect and prevent fraudulent activities. You guys heard of the quants? The people that work, on the stock exchange, and they run all these super complex financial models, and they make tons and tons of money. But I don't know how well they're doing right now because the Reddit people, Wall Street Bets, you heard this? The GameStop stock thing that happened earlier, it's still going on, but apparently that really messed a lot of hedge funds and these quants jobs up because they're completely unpredictable. Let's see. In the insurance field, data mining is used to forecast claims, determine the optimal rate, predict which customers will buy new policies or add on special policy features, and is also used to identify and prevent fraudulent claims. Some more applications. Data mining is used in software and hardware to prevent failures before they occur, identify and filter unwanted content, kind of like the spam filter or folder that we talked about previously, and detect and prevent network security concerns and unsecure products. Data mining is used in the government and defense to forecast the cost of moving equipment and personnel, predict an adversary's moves, and develop successful strategies to predict resource consumption and identify strategies for better knowledge sharing. That's going to be a lot of that linear programming and simulation, prescriptive analytics style. Now seems like a good idea to point out that data mining only works if you both use it and implement what you find. In Homeland Security and law enforcement, data mining is used to identify patterns in terrorist behaviors, discover crime patterns, predict and eliminate biological and chemical attacks, and identify attacks on information infrastructures. In the travel industry, kind of like what we brought up with Google Trends, data mining is used to predict sales of services like seats on airplanes, room types at hotels, and car types in rental companies. It is also used to forecast demand by location, identify the most profitable customers, and retain employees. In healthcare, data mining is used to identify cost-benefit relationships between treatments, determine the most effective strategy, to forecast the level of demand at a specific time and location, and to identify the reasons for customer and employee attrition. So let's remember that healthcare is a business and the medical field is more focused on patient treatment. In the medical field, data mining is used to identify methods to improve the survivability of cancer patients, predict the success rate of organ transplants, and examine genomic relationships and identify patterns between symptoms and illness. Your project in the next class in your capstone would be kind of data mining on healthcare data. So but you're going to look at it from a more operations management perspective. In the entertainment industry, data mining is used to analyze viewer data to predict the timing for TV shows and who to advertise certain offerings 2 for streaming services, is used to determine the financial success of a movie or show before it is produced, to forecast times and locations of events, and to develop optimal pricing policies. Finally, in sports, data mining is used for just about everything. At this point, all sports use it to optimize their chances for a winning season. If you've not seen the movie Moneyball, it looks at exactly this. Focuses on both winning, but also on optimizing profits and managing costs. So the data mining process. Data mining projects have a general process that they follow. Best practices are to create a workflow or simple step-by-step process to maximize the success of the project. There are 3 standard processes that we'll look a little bit more in depth here at the bottom. First process we will look at is the cross-industry standard process for data mining. It has 6 steps, each builds from the other, so paying attention to the earlier steps is important. We will look at these in more depth on the next slide, but this model gives you, an idea of the relationships of the steps. So, step 1 is to develop an understanding of the business and focus on identifying the relevant data. The goal of data mining should be clear and concise. And step 2, we understand the data, which involves understanding the source of the data, where it is stored, data collection process, and the relevant variables. Step 3 is arguably the longest and most important step, the data preparation step. It takes so long because in the real world, as you saw with your lending club data, the data is messy and often incomplete, has outliers and errors and inconsistencies. Actually, a little bit of what we can do in RapidMiner, we can automatically clean data for us, which is pretty cool. But when we get to R, we'll continue learning automated ways to clean data. In step 4, we build the model, as we will assess and compare various models. Models are assessed and evaluated for their accuracy and generality. And finally, the model is deployed. Even with this process outlined, you will find that some of the steps and parts are repeated, especially steps 4 through 6, as we continue to explore and discover the data. Often as you learn more about the data, you'll become more creative and look at different ways or different models or different ways to yield more data. So it's just kind of part of the science of it. So data preparation is a critical task. The chart breaks down kind of the different steps in it. Students often get frustrated with this step, but remember that is meant to take the most time, and we do have some real-world data to work with. So gaining experience with it before you enter the workforce should be beneficial. In the data consolidation step, collect the data, select and filter it, integrate and unify the data. In class, I have done all of this for you. Unless you continue on to get your doctoral degree, that will pretty much always be the case. Data cleaning has several areas to it. First, we need to deal with missing values, and we do that by filling them in with the most appropriate value. Generally, it's the mean. Remember what that was called? No? Come on, Madison. We're going to come back to that. If we have lots of data, otherwise we can remove the record with the missing value, recode the missing values, or we can do nothing if that is appropriate. So next we identify and reduce the noise in the data. Noise is the outliers, which are then removed and smoothed. Then we find it and eliminate errors, such as inconsistent class labels or odd distributions, and correct or remove them. The next step is to transform the data. We do this by normalizing the data, by reducing the range of values to a standard range by scaling or normalization. Then we discretize values that need discrete representation. And for categorical variables, we place them in concept hierarchies. We also create new, more informative variables using mathematical functions. We can reduce the number of attributes using principal component analysis. It's not typically something that we do in this class. That's more research oriented. We can do chi-square testing, correlation analysis, or decision tree induction. We can also reduce the number of records through random sampling. Sometimes it's good to prototype a model with less data because depending on how much consumption your computer is taking. We also want to balance skewed data by oversampling the less represented or undersampling the more represented class. So this will give us all a well-formed data set to develop a model on. So another process used for data mining is called SEMA, which stands for Sample, Explore, Modify, Model, and Assess. 3 steps from the CRISP process need to be done before you can use SEMA. And the SEMA process is generally more experimental. Many methods are available for performing data mining, and we're going to discuss them more in depth as we use several of them in our projects. Classification is the most common method and is part of the machine learning family. It uses supervised learning to learn from past data and to classify new data. The output variable is categorical, which limits the type of data that can be used with that particular method. So we talk about and use regression a lot, so differentiating this term is important. If the thing being predicted is a class label like sunny, rainy, or cloudy, it's classification. And if we're trying to predict an actual number or numeric, we're going to use some form of regression. So both classification and clustering place variables in groups, but classification uses a supervised approach and clustering is an unsupervised approach. We're going to talk about this more in future classes. Assessment methods for classification. There are several methods used to assess the model. Predictive accuracy matches new data to what the model predicted. The data would be to give an accurate rate. Speed looks at how fast it can generate and apply the model to minimize costs associated with time. Robustness measures the model's ability to make accurate predictions. Scalability looks at the ability to construct a prediction model efficiently, even when there is a large amount of data. Interpretability looks at the level of understanding provided by the model, looking at transparency and explainability. In a classification model, the best way to estimate the accuracy of the model is using a confusion matrix. You want to remember this because we're going to use this a lot. So basically you have this chart here of true positives and our positive and negative class for what it actually is, and then what we've predicted it to be. And you can calculate out the accuracy, true positive, true negative, precision, recall. These are all terms we're going to learn a lot more about in the future. But basically, if you are to run a logistic regression model and a naive Bayes model, you use these things to compare which model is better. So which one are you going to actually employ? So, but we'll come back to this and talk about it in more detail when we start doing machine learning. Estimation methodologies for classification. So when we are estimating the accuracy of the model, we split the data into test and train data sets, which we're going to do today. Usually dividing it into 30-70 or 80-20. Very rarely you can get up to like 90-10. It depends on the kind of data you're working with. With an artificial neural network, we split the data into 3 groups, one for training, one for validation, and one for testing. So there is bias and randomly splitting data. So for the breaking it down into training and test data, so we can do something called k-fold cross-validation. It's also called rotation estimation. It splits the data into k mutually exclusive subsets of equal size. Models then trained and tested k times. So it just improves the accuracy and reliability of your models. Another estimation method includes leave one out, bootstrapping, which is a really common one, jackknifing, and the area under the ROC curve or receiver operator curve down here at the bottom. Those are all measurements we'll take. We'll actually take a look at them in RapidMiner 2. Classification techniques. So there are many techniques for classification and modeling. Decision trees. Pretty sure most of you have seen a decision tree in previous class, hopefully. Take another look at this one in future classes. We kind of start out, but there's a lot better things than decision trees. Another technique, our statistical technique, is logistic regression. and discriminant analysis. We will use logistic regression in the second half of the semester in the next class. It's probably the one I use most often in my research. Neural networks and support vector machines are popular machine learning techniques we will use in 606 or 415, depending on which class we're taking. We will talk about them more in the next chapter as well when we look at predictive modeling. Case-based reasoning uses historical cases to recognize commonalities to assign new cases to the most probable category. We also have Bayesian classifiers, which are probability-based or probabilistic models to build classification models. So it's one of the models we'll do in a future class as well. Genetic algorithms use the analogy of natural evolution to build directed search-based mechanisms to classify data. Rough sets sorts class labels into predefined categories to build models. In this class, we really don't use any of those genetic models or search-based. Decision trees. They use many input variables that have an impact on the classification of patterns. The input variables are called attributes, and the output is a class label. The tree consists of branches and leaf nodes. The branches represent the outcomes of a test to classify a pattern. The leaf node is at the end and represents the final class choice of a pattern. All of this can be represented with if-then statements. It accomplishes this to divide the training set until each division has examples from each class. Cluster analysis is a data mining method that classifies items, events, and concepts into groups based on clusters. It can be used automatically to identify natural groups and is a machine learning technique, unsupervised learning technique. It learns how to cluster new instances from past data. Think of clustering like the sorting hat from Harry Potter as it clusters students into their house. I'm not a big Harry Potter fan, actually, but my children love it. Association rule mining. We kind of talked about this with the text mining, also known as affinity analysis or market basket analysis. It is often used to explain what data mining can do and how data mining works and to people that are less technologically inclined. It looks to find relationships between variables in large data sets and how they, the kind of beer and diapers was first noticed was through association rule mining. Also known as finding co-occurrence, but go to data mining software. I'm sure you guys have heard of R at this point, and Excel and RapidMiner are at the top three. Weka, that was really popular like a decade ago. It's pretty advanced software, but at this point R has significantly surpassed it. Stata, SAS, another popular one. MATLAB, I don't know people that use it for data mining at this point. SAS and SPSS both cost money, so they're used more in big business settings. I'm sure you've heard those. I'm sure you've been forced to buy them for a class, not my class. But R, I like it because it's free and it can do everything that those can do. Tableau, if you guys have taken visualization classes, you use Tableau. JMP is basically a cheaper version of SAS. There's Stata. Stata is coming back for econometrics and other, but not as well used in data mining. SAP, Teradata Miner, that's not super popular. But so big data software. I'd say AWS is probably the most widely used at this point. Data mining myths. There are many myths surrounding data mining, and they need to be dealt with before beginning a project, hoping that they are true. As much as we would like, is not a method for providing instant solutions, and it's not applicable to all business applications. In better news, it does not require its own database and can be performed by anyone that learns how. As we will find out, it can be done with smallish amounts of data, and it works for many data types. As we've discussed, data mining goes beyond statistics in many ways, but they really can be used together to make the picture clearer. Some common data mining problems. Selecting the wrong problem for the data mining. I think that's analytics in general. Ignoring what your sponsor thinks data mining is and what it really can and can't do. So you should know, be able to explain what it can do to your boss so they don't try to tell you to do what's beyond the scope of what data mining can do. Not leaving time for data acquisition, selection, and cleaning. Like I said, cleaning is the most time-consuming part. Looking at only aggregated results and not at individual records or predictions, and being sloppy about keeping track of the data mining procedure and results. Okay, now we've predefined the terminology necessary for doing data mining, so now let's do data mining. In the weekly folder, the assignment 5, the Word doc, comes up. We're going to download and get a free educational license for RapidMiner. It's already installed on the lab computer, so you may still need a license, but you should be able to use that to at least run the. So download it, get the license, and then you should get something that looks like this. You guys all set? I don't know how long it takes them to send you a license or not. But let's take a look at the instructions first. So we're going to do the tutorial that's built into RapidMiner. It's right here. It's under help if it doesn't pop up immediately. And we're going to do the first 3, 1 through 8, 6, and 5. These other ones you can do if you want, but you have to connect this one to a database, I think, to be on the scope of this class. And so that's what this. I have version 9 on my computer, but it won't let me update the one on the JU computer. So that is 30 points right there. I'm going to go through the whole tutorial so you can follow along. Then down on the 3rd page here is a text processing tutorial. Tried to clean it up. It used to be on the website, but it was missing a few steps. That's also 30 points. And then the goal of this one will be to recreate this last image, but I'll know who's done the assignment because it'll have a unique timestamp and probably your name on it. And what else? All right, and then the 4th part is a 1-page paper. Write 1-page summary about your experience doing data mining in RapidMiner. And if you found anything new or useful that you did not find in Excel or R. how do people use the software in business, and then 12-point font, Times New Roman, double-spaced, 5 sentences per paragraph, and 2 or less lines of heading. Okay, you guys ready? Okay. So we're going to start with the get started, and we're going to go into operators and processes. So RapidMiner Studio has a lot of features to offer. We're going to go through the main tutorials and setup so you can try to apply this outside of the class. There'll be little like challenge boxes that are in green. So if you want to continue on and see how much you've learned, I suggest you do it. But we'll start with the activity sections, tell you what you're supposed to be doing. So at the top here, we have a repository, and down here we have operators. So we'll pull our data from here, and we'll drop it in, and then all the different models and functions will be down in the operators section. First thing it says go into repository, and we're going to open samples, and go into data, and we're going to look at the Titanic training data. And you point and click and drag it and drop it on that little box. So basically, it's just a function that retrieves data. And we'll pull in some Excel data and some text data in a little bit. So the next thing we have to do is connect the output to the results. So I usually just drag it across with the mouse, but it says you can click on one side and the other, and it'll make the connection for you. So once you've got all your processes in, you hit run, and it will run. So all that did was pull out the raw data that's in that sample set of data. So you have the raw data on this first tab. You can pull some basic descriptive statistics, min, max, average, standard deviation, and charts. There's an entire chart tab. Look at this Titanic data, so we have our dependent variable will be whether or not they survived, and you can look at it by passenger class or whatever. We'll get more into it, but this kind of demonstrates the different kinds of charts that I can do. So continue on. So that's the first part of the first tutorial. I think there's how many were in there? 8. So that's 1 of 8. So in the last tutorial, we pulled in some data. Now let's put a process in, and we're going to run a decision tree on that data set. So the first is to drag the Titanic training data from samples, like we did before, drop it. Then we're going to go down into operators and find, open the folder for modeling. And predictive, and then trees, decision tree. You can also, a lot easier, just type decision or whatever in the box and it'll take you right there, so you don't have to search around in the folders. Now we have to connect the output of our data to train the decision tree, so out to the TRA. Now we want to connect the model to the results. And run, you'll get a decision tree.
Where is run?
No, that's the play button up at the top.
It says I'm missing a label.
Let's see. Did you connect? Let's see. Looks like the method. All right, so you pull Titanic training.
Should I like start over?
Yeah, that's fine. Delete it again because you pulled Titanic. The Titanic training. If you click on it, hit delete. Pull the other one in. You know if it should work. Titanic training, decision tree. And then connect. It still didn't work. Connected the model to the result. Trying to run. Should work. Did you get a license and set it up?
Yeah, I found the instruction design. And then should I try to this one?
Yeah, your reading's turning good. Really should work. There's not much to go wrong. And alright, so when I run, I should get a decision tree based on the sex of the passenger. Obviously, females were the ones who were going to survive. Women and children. So the next step is to download an Excel file. It should auto-populate down. So we're down in the download section. Go through the processes of pulling in an Excel file. So up here at the top, it says add data. Go my computer and change. Select the data, or depending on where you downloaded it.
Where's the Excel file?
It should pop up right here when you're going through the tutorial.
Up on the right.
so then hit next until you get to the same tutorial we're on. You're gonna need to download some data that we're working on. Keep going. Sweet, come back. So that Excel file full, download that. All right, so it pulls that data in. I just left it in the repository, local repository, so it'll just be the only data sitting in there. So then just drag the output to the results section. And you're gonna run, it should pull in your data. So similar to the Titanic training data set, just has a little bit more data, and that would be the process if you wanted to pull any sort of Excel data in to work with. I think on the educational license though, you're very limited on the number of rows of data that you can work with. Here's the green boxes I was talking about. You can choose to do those and determine, you can figure out how to use the software. All right, so that basically goes over how to pull in data. So then we can ask questions about the data and start to analyze it. So in this tutorial, we'll apply a filter to the Titanic data, only look at female passengers, and then we can easily sort the data to find the highest ticket fares paid by women. You can then apply your new skills to answer the same question for men. So do you expect there to be a difference in passenger fare? So we'll pull in our Titanic data from here. And then we're going to search for filter. Filter examples. Connect the output there. And we'll click on filter examples. And we'll want to go over to the parameters tab over here and add a filter. So we want to look at sex equals type. Second operator we're going to add is going to be sort. Search for sort, pull that, and then connect each of the operators and show the result. Then going to sort this by passenger fare. Change this to decreasing. And then you hit run. And we can see the highest fare is 512 and 32. 33 cents, which was a lot for back then. And if you wanted to go back and look at the same thing for man, we would just go back to the design tab, and we can go into our filters, and we would switch this to min instead. All right, so in the next tutorial, we get away from using the Titanic data, and we use some retail data. Where did you?
Sorry, what is it?
Yeah. I left it there in the local store, but you can drop it wherever you want. So in this new data set, we're going to go back to samples. And we're going to pull in products and transactions. And our operators are going to search for join. If you've taken any SQL or the database class, you'll know that there's several different kinds of joins. So make sure we connect both of our data sets into the join. So we click on the join, we're going to deselect, use ID attribute as key. We're going to do product ID, product ID. Primary key and foreign key for those two data sets. Then click apply. The next operator we're going to add is the aggregate function. There it is, under grouping. Connect those. So you click on the aggregate function. And then group by attributes. And we want to group by product ID. Under aggregation attributes, we want to select customer ID. I want to change this to count. And another entry, I want to do product name. We want to set that to mode. And then we can run. So we can sort based on product ID or count of customer ID. So which product has been most often sold? Looks like Athsat. Okay, so we're going to bring back in the transactions and products data. And join them again. Same as before, we have to deselect the attribute as key and tell it which attribute to use as the primary key and foreign key. Then we want to generate attributes. We're going to create a new attribute. We're going to call it total. And then we're going to multiply amount times price. Then we're going to use the select attributes operator. Connect those. We're going to subset the data. Select attributes. We want to keep the customer ID, product name, and the total. And then hit run. Okay, so next tutorial, I'll do changing types. So we're going to go back to our Titanic data. It'll show you that if you hover over out, it'll give you kind of a little cheat shot at what the data looks like. I'll give you some of the same information that's on the statistics tab. It says to note the two columns, role and type. The role of an attribute describes how the column is used by machine learning operators. Also called regular attributes, are used as input for training. All ID attributes are usually ignored by modeling algorithms, so probably a good thing to check if you use this for real data. So now we're going to add the discretize by bin. And connect it. Set this to single. We're going to use age as our attribute and set the number of bins to 3. And add the set role operator. Then in the parameter section, we're going to change the attribute name to survived, target role to label, and then hit run. You can see the statistics, the role of survived has been changed to label. So now we're going to build a survival prediction model based on a decision tree. So we're going to continue using the Titanic data. And we're going to use the set role function. Unfortunately, it's still up. Set survived as label. Next, we're going to do select attributes. A subset. Select attributes. We want survived, sex, passenger class, passenger fare, and number of parents and number of siblings. And hit apply. So now we run. Oh, now we got add decision tree. Okay, let's get started to prepare the data. So this tutorial talks about how to clean data, like I said earlier. Okay, this one starts with the Titanic data that we were using before. It says if you hover over out, and you get this, if you hit F3, it'll keep it there, so you can examine all the variables. Check the column for missing values. We're going to add a select operator. Select attributes. Select attributes and parameters change. It's to subset. We want to select cabin and lifeboat. It says connect this temporarily, and you run it, and it will pull out just that. The next thing is we're going to replace missing values. So earlier I said, what do we call when we replace it with the average? That's called imputation. So we can do that in RapidMiner with the impute missing values. In this tutorials, we use just replace missing values. So we're going to change the attribute type to single, and then type select age. All but that's what there we go. Then age is there. Now we run. Go back to the design tab, and we can look at filter examples. So show advanced parameters, and then no missing attributes. The next is to look for anomalies or outliers in the data. So we pull in Titanic data again. Do select attributes. normalize. Then we're going to look for detect outliers. And finally, filter examples. Add a filter. Outlier equals false. And hit run. So we go back to the design tab. It's going to talk about using a breakpoint. Breakpoint before, breakpoint after. So if your model doesn't work the first time and you know it works up to a certain point, you can put a breakpoint in. And it's a good way to debug code, or in this instance, debug your model in a graphical way. So similar to Excel, you can do pivoting of data. We pull in Titanic data, and we are going to aggregate it. Click on that and do group by passenger class and sex. Do passenger class as a count. Next, we're going to add the pivot operator. Group attribute sex, passenger class as index. And search for operator, rename by replacing. we're going to copy this code and put into the place what. And then copy the $1 and $2 into the replace by. And so similar to a pivot table, it rotates the data and it makes it really concise. Where are we in? 4 of 6. We can also create macros in RapidMiner. First, retrieve the Titanic data. We're going to do set macro. So set macro to fraction. And value to 0.5. Extract macro, and it's in the same folder, so it should be easy to grab. So you want to set macro to size. It should default to number of examples. Next operator is generate macro. Entry. Copy this before we go in there. Copy that function into the expression, and we're going to call that macro new size. Finally, run sample operator. For sample size, we're going to put % new size. And hopefully it runs. Oh. So now we're going to look at sub-processes and running loops. colorless macro, max size, and run it 400 times. So then we're going to add loop values, connect it in. We've got passenger class. Double click on loop values. And inside that loop, we're going to add a filter examples operator. Add a new filter. Passenger class equals percent really brace loop value. So still inside this loop, we're going to add a branch. Set condition type to max examples, condition value to percent. Actually, let me see if I can cut that. Double click to go inside the branch. We're going to connect, because we're not going to use the then part, we're just going to use the else part of this if then statement. Connect that. Set the sample size to percent max size. Go back to the main tab, add an append. And then run. So you may want to export data. So we can do a write Excel function. I don't think we touched on this in R, but you can write data out of R as well. So first we drag the Titanic data in, then we're going to search for the right Excel, and connect it to our data. And the parameters, we want to tell it where we want to write the data. And we're going to call it test. It's going to put it in XLSX format. We're going to store the data. So we want to pick where we want to store it. I'm just going to leave it in the local repository. Hit run. Basically, it's going to take our Titanic data, write it to a CSV in our folder, and store it in our local directory, our local repository. All right, well, let's prepare a data tutorial. The third one is where we run different models. We'll run some of the models I talked about earlier, naive Bayes, I think was one. But we can do some predictive modeling. Next week we'll do predictive modeling in Python, so it'll be a little more code-based and not graphical user interface. So we're going to use the Titanic training data, and we're going to put in a decision tree. A naive Bayes model, which is a probabilistic model, and a rule-based model, rule induction. And connect all the models to the results. Run, and you can see or compare the different ones. The rule-based, it's just an if-then model, very similar to what you see in the decision tree, just not branched out. And you can look at how the naive Bayes model is distributed. I'll come back to these in a second, and we'll actually compare them with the AUC curve that we talked about earlier. So the next thing with the prediction models, we're going to do something called scoring. So take our Titanic training data and the naive Bayes operator. Then we're going to take our unlabeled data and drop it here. And then use the apply model function. Connect it. Follow along. And then connect the model part, I think. then we can run. Basically what this is going to do is we're going to use our training set, run the naive Bayes model, and based on the output of that model, we're going to label the unlabeled data or make the prediction on it. So in our unlabeled data, it'll make a prediction on whether or not those passengers would have survived based on a naive Bayes model. So earlier we talked about splitting data into training and test sets. So we're going to take care of that now. Take Titanic training data. And there's an operator called split data. Connect that in. We can go into edit enumeration. Ratio. We want to add 2. First one, we want to put 0.7 for 70%, and the second part 0.3. So that'll give us our 70-30 split. Then we'll add a naive Bayes model. Set that up for training. Oops, the apply model there. So I'll add the apply model. I can connect that in. Basically what it's going to do is it's going to take this training data, split it 70-30, train a naive Bayes model on 70%, and then test 30%. And then since the data is already labeled, we can see how are the kind of the quality of our prediction. Performance. So the performance operator here will calculate out our accuracy, or 80% accurate into predicting the survival rate, precision, recall. There's different, well, they're all the same in this case. Area under the curve, or AUC, ROC curves. So when you're trying to optimize or fine-tune models, you'll try to get this lift higher. Like I said, we'll talk more about that in a future class when we really get into running this on real data. Okay, almost done with that. We talked a little bit about cross-validation. So we can look at that. Retrieve the Titanic training data. We're going to add the cross-validation operator. So we want to double click on the cross-validation. And we're going to add a decision tree to the training part. And we're going to add the apply model on the right. As well as performance. Here. model. Check this. I think I did that right. Back to main process. Green model. Results. Okay. So runs a decision tree with cross-validation. I never got the carrots to show up, but we can change the number of folds or cross-validations here. And then I can run the process again. And third, let's see, here we can pull up the ROC curves. Double click on compare ROCs, the process. And we're going to add our 3 models like we did earlier. And connect an input to each of those so that we can train it. And connect the output of each of those models. Go back to connect the ROC port to the results because that's what we're interested in. We should run. Now we can get 3 ROC curves. Which one's the best? Obviously the decision tree because it has the best curve. Okay, then when you get to this part, take a screenshot. It says take a selfie, so I can make sure you're not just sending the screenshot around. Hopefully everybody made it through that part of the tutorial. Next part is the text mining part. You guys caught up to this part? How far back do you want me to go? I don't have any sound on this.
What do we need to take a screenshot?
So after you finish the tutorials of this section here, just showing that you did 8 of 8, 6 of 6, and 5 of 5. It's only those first 3. The second part of it, when we get to the text processing, you need to recreate this final, not that one, this one.
This first one doesn't need a timestamp, does it?
No, cause, I mean,
On my screen, it only gets that box.
only here. Yeah, when we get
But I
to,
don't need a timestamp, that's not.
so usually I can tell if somebody's safe based on if their computer name is up here, but it depends. The timestamp, when we do the text mining part, I've had people just turn in the same screenshot, and this screenshot's from 2013, so that's pretty easy to tell. So don't do that. Do you guys want to take a break? And then we'll come back and do the text processing. I can help anybody who's gotten lost along the way. I can't wait to see the selfies. So you guys online, I guess this computer was on mute. So if you've been talking, regrettably, I just saw that. I was wondering why it was so quiet out there.
You said we're still doing this LP if we did it class.
I mean, it's really just to make sure you did it because really against doing a selfie. I don't usually do this as an in-class assignment, but I've had enough students struggle with it that I thought it would be beneficial to some.
Sir, does this work for the picture? Because I'm not sure how I'm going to take a selfie with the actual computer. Guys. I took a piece of paper and wrote my name and the
That's
date on
fine.
it.
Oh, the other thing I wanted to mention, two people dropped in class, so I don't think they have a group member. So there's another girl, Eve Shen, she's online, but she wants to do it by herself. If you want to do it by yourself, that's cool. If you want, sure. At this point. Yeah, I want you guys to have to, she said she'd already worked on it, so start over.
Mine like.
I go back to that, I'll try to set it up again. Because there's two spots, because I went through it earlier today and double checked, but I got, it's usually where we had to put in the functions. So let's go back. training data. We put in cross validation. Okay, so we double click on it. On the training side, we put a decision tree. Training model. Training fourth training day on the left, output model on the right. Apply. And performance. Model. Connection is missing. Let's move back. No check marks by the subjects. So check marks come if you're working through the tutorial. Okay, let me get a drink real quick. And then we can start on the next process. So the first thing we have to do inside RapidMiner is go up into extensions and go into the marketplace. Okay. And I have to switch to my computer. Well, if you're not on a school computer, go into extensions, marketplace. This will pop up and you'll type in text processing and you'll download that. I figured out how I can make my computer connect.
Are you working
Yeah.
this marketplace or extensions and what?
Okay, so I go extensions, marketplace. It stole my HDMI cable. But it's in there, and you should get like a little search box, and on the left there'll be where you search and you type in text processing. So, but if I know, I would take a screenshot of that. No, it won't let me do it on my laptop. Should. Did you guys get it to come up? You did? I don't know why mine's not coming up.
It worked on this computer too.
Huh. It's gonna be problematic. You have to download it to get the operators. Hmm. Let's see. I can make this work. I'm gonna switch to my laptop and collaborate and see if that works. Try this. See how this goes. Okay. Okay. It's a little blurry when you do it that way. Anyway. All right. So we'll come back to this. And then I have the text mining under extensions, marketplace, text processing. Hopefully you pulled it up. We're going to pull, so you hit control on a list on a PC and left click. And we're gonna download the entire works of Mark Twain. I'm gonna hit Control A, Control C to copy it. Kind of like when we were doing text mining before, we're going to save it in a text file. Save it on the desktop, call it Twain. I already did it earlier, so that will give us our data set. Back here. Right here. Start with a blank process. So if you have it installed, you will get different functions based on installing that extension. So there are multiple read operators. Let's see. We want to read document. This one. We're going to read document, drop that in there. Drag that over. And the document we're going to read, we're going to put here. I have it on my desktop. Twain.txt.
Is that in transformation?
Which one?
Read document?
Under text processing, read document. Okay, so continuing on, we select the file that we want using the Twain file. And chosen the file. I click the play button. And it should pull that all in. get something that looks like this. Just double check. Okay, so now I got the data in. So now we want to start processing to get, or start doing the text mining like we did in R. So we're going to pull in process document on the design tab. Process. I think that's the one we want. Connect that. Document. Words. Let me double click our process document. Inside of the process documents operator. So we're going to tokenize and do like a bag of words. First one. It's up here. Tokenize. We're going to filter and filter stock words, filter tokens by link. So for this, I think it's easier to go under text processing folder and then go into the filtering methods. Then we want to filter stop words in English. Filter tokens by a link. And just connect those off.
What's the first box? The first one.
The tokenize.
Like the
Filter stop words.
Is it?
Filter stop words English. It's right here. Under text processing, then filtering, filter stop words English. Okay. Stop words. Tokens, we want to do 3 and 100, I think. The minimum word length will be 3. And 100 should ensure that any word length is accepted. Case and transform pieces. To lowercase. Can we hit play? You should get a table, kind of like we did with the text mining before. Like I said, you should have a unique timestamp. Okay, that you did it. So then take a screenshot of that, and I think that's another 30 points. Okay. So for what you turn in, it's the screenshot from before of the tutorials, screenshot with the results here, this page, and then the one-page paper indicated here. Let's see what you guys are. How far do you want me to go back, James? Process doc. So for transform cases, it's lowercase. For filter tokens by length, it's 3 and 100.
What does your result look like?
Should be a table there and a by.
So delete that.
What is your text file?
Yours is
Oh,
Oh,
It's all going across.
yeah. Although.
Open the text document.
happens if you just pull that off and just read the document? You go back to that.
Okay, so the top process goes on. Did you connect both the XA and work to results?
No.
Oh, there we
You get a show?
Yeah, the log, you search it in the top right hand corner, and the search just says log. And then it'll say actions display panel semicolon log.
So just click.
Yeah, and we click on that.
So on my results tab it pops up. I don't know why that's. Anybody else? Check. Everybody good online? Cool. So that's all for today. If you've made it that far, then you're set.
Go back to that tab. Take the words part. Oh, yeah. Both will connect. Okay, so now when you run. No, no. Full log.
This week.
So type log up. Oh, log up. Just display log. That might go all the time. So.
And then just take a screenshot.
No, it's not.
Yeah, so I think Brenda does that. Okay. So, you know, they have fast passes. Yeah. So this is what the they're not gonna have passes also. So they're gonna be, it's gonna be Disney Genius. I'm gonna real experience that work really learn so much miles and where you want to be it. And you want to do the thing. And we would pay extra if you were paying the fast pass meals for like. But it's like not rolled out yet, so they want to keep like super limited. But I'll do some more research on it.
So you're gonna connect those two tokenize.
But yeah, it's like super great, it just says like it's gonna roll it out this fall. It's a complimentary free new digital service design for us.
No, they still have but in filter stuff where it's like filter token.
Yeah, I'll like do one of the two. I can't even say that, I'm totally invisible, so I'm hating on people. Yeah.
Connect that, you want to change that to 3.
Right, yeah. We like used to go, they used to have a vacation we could take some. I was like, cause Disney, when we go, we stay in everything's done for you. You don't have to worry about what you're doing for the day, you just have to worry about what you're there, you kind of figure it out. As opposed to, we're going to go home, and we have to like, yeah, what we're doing each day. But attractions are not attractions, but sightseeing and stuff like that, and Disney's just like done for you. So that was always what we would do. And so I'm walking with this one for hours. But yeah, it's just, it's so expensive. Darn, I got to go to all 4 parks. Oops. No, when I moved out, I annual pass, and I was like, I've literally, I think I've done it Disney once, and then it's been 6 years. Yeah. I feel like maybe just the girls. Like, I think that beauty of Disney is like, as opposed to like, Right. think they like did it from last year to this year, but like now they're back up for school or something. So they wasn't good about taking LCCs this year. Alright. I won't be here next week, so.
All good?
See you next week.
Yep.
Yeah. So, and that's what I'm also, so. You record our classes, right?
Yeah.
Okay, I just may not be able to attend next week.
No worries.
I'm
Oh,
flying
well,
home, so I may be on an airplane.
Next week we're learning Python, so that's not a good way to miss. But as long as you watch the
I've already
video.
done it once, so.
No, you haven't. We haven't done Python.
One of my other classes I have.
Okay.
It's not, yeah.
Well, if you know Python already, then yeah, you should be all right.
Okay, but I mean, if it's recorded, I'll just follow along. I'm gonna see. I don't know why. I might like during class be switching planes, so I might be able to log in, but I'm not sure.
Okay. It
I haven't
should.
looked that deep into it. All my mom said was, "Here was a plane ticket."
Oh, nice.
So.
Yeah.
Thank you.
Okay, no problem. Anybody need any help from me? So, which one is that under? Up here? Oh well. Changing types and roles. Oh. Let's see. So you should have your parameters on the right side. Can you get it to come up? So, it's just there. Subset. So we'll end up getting to here.
I don't know what it's on. Sounds because it's on my. How you get parameters to pop up if they're not.
Did the side panel go away? Oh, okay, that happened to me earlier too. I think that's the work. I think it, future. You're like trying to get that bar over here and come back. It was. What was it? There's like a button somewhere up here that says, there, restore default view. There you go.
There you go.
That exact same thing happened to me while I was trying to do it, and
I've never had, like, I always have the same view. So I've never.
I closed stuff.
Oh,
That was
okay.
my fault. It was my fault, but.
It's good to know for future. We're never going to use this software again in this program, but it's good for demonstrating kind of a visual way of data mining. Because once we get into R, we got coding.
What is it, industry, or is that minor?
You can find it on as a job skill on jobs.
Like
Yeah.
insurance industry?
I don't know. Let's see. Let's see. Not in Jacksonville. Not too much. There's accounting. It was a lot more popular several years ago. That's why. I think it's a good for teaching tool, but as for the real world, R and Python are going to be skills that you're going to make a lot more money, and it's going to have a lot more job openings. So we're going to learn Python next week. So.
Cool.